What if the reality we see is just a thin layer of something much deeper? What if there are dimensions beyond our own, possibly even other worlds, that we can't readily access, but science is proving that they exist? As a Christian, we have believed this from the beginning. It is a fundamental teaching. But science has been slow to accept this concept until now. Have you ever wondered about the origin of aliens, ghosts, or demons? Have you ever asked your priest or pastor if the Bible can explain these things, only to come away with no real answers? Well, I don't know about you, but I have. So, I've spent 15 years researching these topics, and I've come away with a very compelling explanation for many of the world's mysteries. I'd like to start a conversation about the things your pastor is afraid to talk about. This is Audra Moore, and you're listening to Evil's Ancient Origins. In today's episode, we're diving into the mysterious world of quantum mechanics and covering a few of the latest cutting-edge advancements causing scientists to question the very nature of reality. Ancient texts such as the Bible, Hindu scripts, and even the Quran have already known about and even described these concepts. Have you ever heard about Google's new quantum processor called Willow? Its debut was announced in December of 2024 through a blog post for a London-based weekly scientific journal called Nature. Willow is the latest release in a series of quantum processors that Google has been working on. Google says that as a benchmark, Willow has been able to complete a random circuit sampling in 5 minutes, which would take today's fastest supercomputer 10 septillion years. That's 10 to the 25th power. Yikes. According to Wikipedia, the release of Willow prompted optimism in accelerating applications in pharmaceuticals, material science, logistics, drug discovery, and energy grid allocations. All very noble causes. But it goes on to say that popular media responses discussed its risk in breaking cryptographic systems. The coding used to protect banking processes and sensitive communications, as well as other important things. But a Google spokesman said that they were still at least 10 years out from breaking such public key crypto systems. So I'd like to see how they figure that. 10 years, that's quite exact. According to Google's Quantum Artificial Intelligence Laboratories founder, Hartmut Neven, who has been developing quantum computers since 2012, unlike standard computers, which operate on a binary system of zeros and ones, a quantum computer replaces the binary logic with the laws of quantum physics, giving it more powerful operations. He says in his July 2024 TED Talk that quantum computing is the first technology that takes seriously the idea that we live in a multiverse and that it can be seen as farming out computations to parallel universes. These are bold claims. Indeed. How can they truly determine where these calculations are being processed? It's as if they're just calculating them out of thin air. From my understanding, a quantum system runs its computations in superposition, meaning that instead of bits, which are represented in code as a 1 or a 0, with a quantum processor, the bits are replaced with qubits. that have a value of either a 1 or a 0, or both a 1 and a 0. Scientists theorize that this is based on its ability to interact with other dimensions through entanglement. According to TechTarget's website, quantum superposition is the ability of a quantum system to act as if it is in multiple states at the same time until it is measured. And that superposition is a property of all wave functions. This is one of the foundational principles of quantum mechanics, wave-particle duality, which states that particles of light and matter can behave like both classical particles and classical waves. This duality is what allows the qubit to be multiple values at once. This discovery is famously demonstrated in the double-slit experiment, where two particles, such as electrons or photons, are fired through two slits on an iron plate, and they're fired onto a screen behind that plate. When observed, they behave like particles passing through one slit or the other. However, when not observed, they create an interference pattern on the screen, as if they're behaving like waves passing through both slits simultaneously. When I first stumbled across the double-slit experiment, I was so excited to imagine that when no one is looking, the basic building blocks of everything are without form. Doesn't that harken back to the first chapter of Genesis, where it says, "The earth was without form and void, and darkness was over the face of the deep, and the Spirit of God was hovering over the face of the waters. And God said, 'Let there be light,' and there was light." So it was his observation, his appointment to these photons to just be in one state or another, to produce light. According to Wikipedia, a double-slit experiment was first performed by Thomas Young in 1801 as a demonstration of the wave behavior of visible light. Then, in 1927, Davison and Germer of Bell Labs finalized an experiment in which electrons scattered by the surface of a crystal of nickel metal displayed a diffraction pattern like a wave, confirming the hypothesis of wave-particle duality. Now, the other key to a functional quantum processor is the necessity of entanglement. Entanglement occurs when two particles become linked and their properties are instantaneously connected, regardless of the distance between them. If you measure one particle, you instantly know the state of the other particle, even if it's like light years away. This is how they can observe its function without it collapsing, because observation makes it change its state. This entanglement allows scientists to analyze one qubit without disturbing the original, which stays in a state of superposition, since it isn't being directly observed. I'm hoping this makes sense, and I'm hoping that I'm portraying it correctly, so bear with me. Now, Albert Einstein called it spooky action at a distance because it seemed to defy the laws of space and time. However, modern experiments have repeatedly confirmed that entanglement is real. According to Live Science, there are many ways to entangle particles. One method is to cool the particles and place them close enough together so that their quantum states overlap, making it impossible to distinguish one particle from the other. According to Wikipedia, another example of entanglement is a subatomic particle that decays into an entangled pair of other particles. The two daughter particles are entangled, meaning each portray the same behavior as the other in an equal and opposite action, obeying the basic conservation laws of physics. And according to NASA, it's also possible to create entangled pairs of photons or particles of light by either splitting a single photon and generating a pair of photons in the process, or by mixing pairs of photons in a fiber optic cable. Scientists claim that this entanglement hints at the existence of parallel universes or hidden dimensions. Theories of quantum mechanics suggest that entangled particles might be communicating through dimensions that we can't see or access directly. Theories surrounding what these other dimensions are and how they present themselves are numerous, vary drastically, and each theorizing scientist stands firmly on their own interpretation. According to Wikipedia, the concept of multiple universes, or a multiverse, has been discussed throughout history. It is evolving and has been debated in various fields, including cosmology, physics, and philosophy. Some physicists argue that the multiverse is a philosophical notion rather than a scientific hypothesis, as it cannot be empirically falsified. The ideas defining multiple universes explore various dimensions of space, physical laws, and mathematical structures to explain their existence and interactions. Some of the multiverse concepts include holographic, twin world models, the many worlds interpretation, simulation, cyclic theories, M theory, and black hole cosmology. One organization exploring these topics is CERN, the European Organization for Nuclear Research, home of the Large Hadron Collider, the world's largest and most powerful particle accelerator. Scientists at CERN are experimenting with high-energy collisions to discover new particles and explore the fundamental forces of nature. In November of 2009, as the collider was coming back online after significant upgrades had been made, there was speculation that upon its activation, the machine would create an entry into unknown dimensions. The director of research and scientific computing for CERN at that time, Sergio Bertolucci, was quoted by a science periodical called The Register as saying, "Out of this door might come something, or we might send something through it." Now, that quote used to be on the CERN website. I searched and could not find it. But years ago, I remember reading it on their website. So I was lucky to find the actual article by the Register, and it's linked in the notes below. So this spurred on speculation about parallel universes and the idea that CERN was able to manipulate or access other dimensions. Seeing as CERN has had a few upgrades since then, I would imagine that they have achieved even higher levels of experimentation. A more recent article, appearing in September of 2024 on the CERN website, claims that among the many accomplishments that they have achieved over their 70 years of experimentation, they've observed quantum entanglement at the highest energy yet. As a side note, there's a statue of Shiva on the campus at CERN, which symbolizes the cosmic dance of creation and destruction, reflecting the scientific exploration of the universe. It was a gift from India to celebrate the long-standing collaboration between India and CERN. I can see how the collision of atoms embodies destruction and how their discovery of the Higgs boson represents creation, seeing as it is called the God particle. But I'm wondering, At what point does the concern of negative consequences outweigh the potential for discovery? Scientists there have likened what they do to creating a mini black hole or simulating the conditions of the Big Bang. Just what can be done to prevent something from going wildly awry when you venture so deeply into uncharted territories? And this has been a concern for many years. The concept of multiple dimensions is nothing new. Ancient texts such as the Bible, the Puranas, and the Quran have mentioned multiple realms beyond our physical world. So, for instance, the Bible speaks of heaven and hell as realms that exist beyond our dimension. The Quran also mentions 7 heavens and the possibility of journeying to these realms. The Puranas are a collection of ancient Hindu texts that contain various stories and teachings, and according to Vedic Feed, it describes multiple lokas or realms that exist in the universe, which is inhabited by various beings, including gods, demons, and humans. If quantum mechanics is hinting at multiple dimensions, could these dimensions align with religious descriptions of these spiritual realms? Could heaven and hell be understood as higher or lower dimensions? Is it possible that the portal CERN is opening could lead to realms that resemble these ancient descriptions? Are these entangled qubits communicating from beyond the plane of existence that we call our own? Science and spirituality have often been seen as two opposing forces, but the more we learn about the quantum world, the more we realize that both may be addressing similar truths from different angles. The idea of higher dimensions in quantum physics are not so different from what has been described in these ancient texts. But the scientific experiments involving quantum computers touch on the most puzzling aspect of quantum mechanics, the idea that observation affects reality. So they state that the very act of measuring a qubit can collapse it into a specific singular state. So this is what physicists refer to as the observer effect. This property of quantum computers creates many challenges that scientists are constantly struggling to overcome and can even make their computations less accurate. So my question is, how do these particles seem to know when they're being observed? Does this imply that our consciousness plays a role in shaping the outcome of their computations and ultimately reality itself? Since all particles are originally quantum in nature, doesn't this lend credence to the concept of faith, prayer, and healing? As I stated in my previous episode, which explored the adventure app called Randonautica, I believe that the Bible supports this theory as we come into alignment with God through prayer and having the faith of a mustard seed, connect with God's power, then we can move mountains if we truly believe. Wikipedia states that within physical cosmology, the fine-tuned universe is the hypothesis that because life as we know it could not exist if the constants of nature, such as the electron charge and the gravitational constant and others, had been even slightly different, that the universe must be tuned specifically for life. The very order of the universe proclaims that there is a creator. Whether it's quantum entanglement, the double-slit experiment, or CERN's exploration of the unknown, what we're learning about our existence is stretching the boundaries of man's imagination. And just as ancient texts describe realms beyond our own, modern science might be on the verge of uncovering these new dimensions, which will forever change how we understand our existence. But the constants of nature will always portray the signature of the one true creator of all things. Now, this episode is an attempt to lay the groundwork for some deeper discussions, things that I want to address in the future, and one of them is about that Willow processor. It turns out that a short time after Google's Willow processor was unveiled, the team had to shut it down. And in my next episode, I'll be going over why they decided to shut it down and discuss what this may imply. They seem to have it up and running again, but I still have some questions. So I hope you join us again next time when we start another conversation about the things your pastor is afraid to talk about. This is Audra Moore, and you're listening to Evil's Ancient Origins. Look for us next time on YouTube, Spotify, or wherever your favorite podcasts are found.